All right, welcome, welcome, welcome. For today, we are going to learn how to multiply polynomials. Go ahead and get a piece of pen, paper, so you could write on it, okay? And follow as I go along. Remember, this is being recorded, so you could always go back. Rewind, fast forward, pause, stop, okay? Go back and watch them. In order to be successful, you have to be able to combine like terms, simplify terms, but then also understand how exponents work. We're going to go through a lot of that right now. Let me pull this whiteboard up and we'll get to going. So we're going to be learning how to multiply polynomials. And again, this has a lot to do with the distributive property. But before we do that, I want to get into some stuff. So with exponents, when exponents are similar, so like terms, sorry, not exponents, when the base are similar, bases are similar, then the exponents are added. And we kind of touched on this in 7th grade. I introduced you to it so that this time around it's a little bit easier. All right, so say for instance I had x, nope, not that color. Say for instance I had x squared times x to the third. So the definition says when the bases are similar, the exponents are added. So the base, which is x, they are like terms. Not necessarily like terms, but they are similar, so then I add them. So then the answer to this would be x to the 5th power. I add the exponent, so this is really x to the 2 plus 3. The bases are similar, right? The bases are similar, so I add the exponent. So then my answer becomes that. I'll try and tie in the like terms after. If I was adding these two, if say for instance this wasn't a multiply button, I couldn't do anything because they're not like terms. But when I'm multiplying, they aren't like terms, but because I'm multiplying and they have the same base, I could add the exponents. I'm gonna let that sink in for a minute. Let's do one more example. X times x squared. This is technically saying x to the 1st power. I don't need to put it though, because, okay? So x to the 1st power times x to the 2nd power. If this was addition or subtraction, I couldn't do anything with it because they're not like terms. I'm multiplying, and because I'm multiplying and the bases are the same, my answer becomes x, and then my rule says I add the exponents. So my answer becomes x to the 1 plus 2, which means my answer is x cubed. That's it. We're multiplying exponents, multiplying polynomials. And we'll try and put this in polynomial form. And we'll see. Okay, let's do one more example. Y, let's increase it. X, y times, right? Then my next one is x squared y. Okay, So if I'm going to do this, I'm going to do the same addition with the x's and the y's. All right. This is basically saying x to the 1 and y to the 1. That's what it's saying. And this is y to the 1. So when I add these, I get x to the third power and y to the second power. I do 2, or do 1 plus 2, and then 1 plus 1. If I had x, y times x. Could someone please tell me in the chat, what would this one be? If I was adding, I wouldn't. So for this one, my answer would be x squared y. Now let's do an example where we're including the whole polynomial stuff. All right. So here, so say for instance, we have this example. And when you multiply, do the distributive property, negative x times xy would be negative x squared y, because a negative times a positive is negative. X times xy is x squared y. Now let's do the other part. A negative times a negative is positive, right? And then my answer becomes 2x squared. Technically, there are ones here, but we don't need to write the ones. So whenever we're multiplying, right? When we're multiplying, we add the exponents. And with this one, I can't do anything else with this right here because they're not like terms. You see how we switched it from the multiplying to the addition? What we've been doing before was the addition part, right? I can't do anything with negative x squared y plus 2x squared. They're not like terms. But before, I could have multiplied when they're not like terms. Let's do one where the polynomial is even more extensive. So let's go back to that first example we were doing. It says minus x times xy minus 2x plus y times x minus, let's do plus 4. Let's make this squared. Okay, so you guys put in the chat, tell me what my first step is. What's the property, the first step? I'm going to do the distributive property. So if I'm doing the distributive property, it means that I'm going to do that, that, okay? And then if I'm going to continue that, this becomes negative x squared y plus 2x squared plus x squared y. And you realize that I put my x squared first before the y because I realized that there was one over here. Plus 4y. Now, could you put in the chat, what would I do next? Like, does this look familiar? What do I do after this part? I would group like terms. That is correct. So right here, I realized that my only like terms here is this x squared y and this x squared y. But one is a minus and one is a plus. I know that's going to cancel. I'm not going to go about and rewrite this whole thing. I know that I'm going to have 2x squared left and the plus 4y. So my answer is 2x squared plus 4y. And that's how we solve when we're multiplying with polynomials and all these different things. So we do the distributive property, multiply out, we group like terms, and we simplify. All we really need to remember when we're multiplying polynomials is, let me go back to this right here, is that we add the exponents when we're multiplying. The signs and all that stuff still is a part of it. So if it's a negative times a positive, it's a negative. It's a negative times a negative, it's a negative. All that is still in play. What we need to remember, though, is whenever we're multiplying like variables and stuff, once the base is the same, we add the exponents. Keep in mind, when the base is the same, we add the exponent. So I want us to look at this right here so that we don't make the mistake. So if I say y squared times x squared, and if we say y squared times y to the 1, could you give me, let's say squared here too. What would be the answer for both of these right here? Yes, that's correct. This one would be y squared x squared. I can't do anything to the exponents because the bases are different, okay? But with this one, since the base is the same, this becomes y to the 4th. That's absolutely it. Once the bases are the same, we add the exponent. If they're not, we just have to keep them together. Recording. Could someone put in the chat any idea what happens when we're dividing polynomials? Yep, ding, 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 ding. That's it. You see how this is easy? This is why multiply and addition goes together, and divide and minus subtracting it goes together. So if I have an example that says x squared divided by x to the 4th, what would be my answer for that one? So with this one, I'll do x and then 2 minus 4. Instead of adding, I'm subtracting, right? Instead of adding, I'm subtracting. So then this is x to the negative 2, because 2 minus 4 is negative 2. Okay, so if I'm dividing, then this becomes x minus x to the 2 minus 4. I saw someone put something in the chat saying it would be negative x to the 2. This right here is something completely different from this, okay? So we don't want to make that mistake. And again, the bases have to be the same when I'm multiplying and dividing for me to be able to subtract the exponents. That's kind of how we do multiplying and dividing exponents. One thing I want us to look at, and I'm going to put it over here to the side. Okay, if I have x to the minus 2, that is the same thing as 1 over x squared. So in order to make x to the negative 2 positive, I just put put it over 1. No, I put 1 over it. Yes, that is correct. Okay, so if I have, say for instance, another one, y to the negative 20, and I want to make this a positive, okay? If I want to make that a positive, I just put 1 over y to the 20th power. That's basically it. If I'm going to do another example, say for instance I had 1, let's turn it around on you. Let's see how you do this one. 1 over x to the negative 4. What would that answer be? 1 over x to the negative 4. How do I make this positive? Yes, look, I just flip it. What I'm telling you, what I'm trying to show you is that when we are dealing with exponents, when we flip it, it becomes positive. All right. So yes, this is negative right now. If I just flip it and put it over, this is over 1. I just didn't write over 1 because I don't need to write over 1. That makes it positive. All right. If it was the other way around, just x equals, x to the negative 4th. If I want to make this positive, then I have to put 1 over it. All right. What I don't want us to make the mistake of, and I'll do it on here so that we're aware of it. If I have negative x to the negative 4, do you realize I put a negative in front? I can't get rid of this negative right here unless I multiply by -1, because then it makes it positive. However, we're talking about the negative in the exponent. So this would be 1 over negative x to the positive 4. Flipping it only makes the exponent change. It has nothing, absolutely nothing to do with that negative in front. Okay? So that's just a couple things that I want us to remember. The first one is when we're multiplying exponents, the base needs to be the same and you add the exponent. When we're dividing it, the base needs to be the same, but we subtract the exponents. And then when we're trying to change an exponent to being positive, if it's on top, we bring it to the bottom. If it's at the bottom, we bring it to the top. That's it.